Welcome to the problem solving session for the week 5 on the topic hydrological analysis of runoff for the course surface water hydrology being taken by Professor Dr. Rajiv Maiti from the Department of Civil Engineering IIT Kharagpur. This is your TA Aman Srivastava, and today we will be solving some numerical problem on this topic which will help you to solve the weekly assignment being provided from NPTEL forum. Today in this session we will be focusing on these three aspects of hydrological analysis of runoff, that is to calculate the runoff, secondly to analyze the rainfall runoff correlation, and thirdly to see the application of SCS-CN method. So let's start with the first question in the today's session. Let me read the problem for you. A catchment has an area of 800 km square. The average rainfall depth the catchment receives during a monsoon period is 100 centimeter, while direct runoff measured at its outlet during the same period is estimated to be 5 into 10 power 7 meter cube. What percentage of rainfall has become runoff? So here the catchment area has been provided. Also the input to the system or input to the catchment is also provided in the form of monsoon rainfall, which is 100 centimeter, and output is also provided from the same catchment in the form of runoff. So we need to find out how much was the percentage of runoff from this input rainfall in the given catchment. So let's see how to solve this problem. In the first step, we will be finding the direct runoff depth, because the direct runoff volume has been provided to us, as you can see in this equation, and catchment area is also provided to us. By substituting the value of direct runoff volume, that is 5 into 10 power 7 meter cube, and catchment area, that is 800 into 10 power 6 meter square, we have converted the kilometer into meter square. By multiplying 10 power 6 to 800, we get the runoff depth as 0.0625 meter. In step 2, we need to find out the percentage of rainfall that has become runoff, which is the ultimate target of this question. So this can be done by equating by finding the ratio of direct runoff depth that we have identified in the previous step and dividing it by rainfall depth, multiplying it with 100 to get the percentage. So here we now know that the direct runoff depth is 0.0625 meter and the rainfall depth, which is 100 centimeter provided in the question. So I converted that 100 centimeter into meter by dividing it by 100, and then I got the percentage of B, that is the rainfall, that is the runoff percentage from the total rainfall as 6.25%. So this is the final answer. I hope you were able to follow this question and the response that has been described in 2 steps. Let's move ahead and solve second question on rainfall runoff correlation. Let me read the problem for you. A linear regression relationship between runoff R and rainfall P has been established as R is equal to AP plus B. The plot of the line intersects the x-axis rainfall at 40 mm and the slope is 0.6. So there are 2 parts of this question. First part, find the linear regression equation for the above condition, and second part is, if precipitation P is 100 mm, what is the corresponding runoff obtained from the equation? So let's see how to solve this problem. In the step 1, let's interpret the equation R equal to AP plus B. So here the slope of the regression line is provided, which is 0.6, and this 0.6 is nothing but A in this equation. Also in the problem, regression line intersects the x-axis at 40 mm is provided. So what does that mean? This means that the value of B has been provided to us, which is y-intercept, and that is negative, and it can be calculated as B is equal to 0.6, that is the slope, into 40 mm. So it yields 24 mm, and this is what is the y-intercept or B value in this equation. Now we can obtain the linear regression equation by substituting the value of A and B in the main equation. So we get R is equal to 0.6 P minus 24 as the linear regression equation for the given conditions. And this is how we can plot the equation R equal to 0.6 P minus 24. Here you can see that on x-axis, here is the point where 40 mm is intersecting the x-axis, and while this is the point where minus 24 can be seen, as you can see there is a minus signature, minus sign. That's why the point here is located below the 0 on the y-axis, on the negative y-axis. Moving ahead, let's solve the another part of this problem. In the step 3, we will find the runoff corresponding to a rainfall depth of 100 mm. So how to obtain this? Now we know that our equation is R equal to 0.6 P minus 24, and the P value has been given to us, which is 100 mm. So let's substitute this P value in this equation to get the runoff depth. So now it's very simple. 0.6 into 100. 100 is the depth of the rainfall which is provided in the problem, minus 24, and we get 36 mm as the you were able to follow the response described in 3 steps in this problem. Let's move ahead and solve the last problem, which is the application of SCSCN method. Here SCSCN stands for Soil Conservation Services Curve Number Method. Let me read the problem for you. In a 200 hectare watershed, the CN3 value is estimated as 80. Estimate the runoff volume due to 2 consecutive days of rainfall given in the following table. Use standard SCSCN equation and assume AMC, that is antecedent moisture condition of type 3. As you can see in this table, the information of 2-day rainfall has been provided. On day 1, the rainfall in mm was 82, and on day 2, the rainfall which was received in the catchment of area 200 hectare is 60 mm. So now, keeping all this information intact, let's see how to solve such problems. In the step 1, let's find out the potential maximum retention denoted by S for the basin having the curve number 3 as 80. Okay, so how to obtain this? This is a standard equation, S equal to 254 in the bracket 100 by Cn minus 1. So Cn value has been provided, which is 80. Substituting that value here, we obtain potential maximum retention S as 63.5 mm. In the step 2, let's find out the relevant equation for estimating the runoff Q. In the present problem, as we can see that the rainfall P1 82 mm and P2 60 mm for day 1 and day 2 has been provided. Now what we have to check here is whether this P precipitation value is greater than 0.2 times the rainfall value, 0.2 times the potential maximum retention, that is S. So if we check, or if we multiply 0.2 with the value of S, which is obtained as 63.5, we obtain 12.7 mm. As we can see here that both the P1 and P2 value is greater than 12.7 mm value. Under such condition, we can use this equation which is displayed on your screen. Q is equal to P minus 0.2 S bracket whole square divided by P plus 0.8 S, which is suitable for the present condition, that is P greater than 12.7 mm. Okay, now we have decided in step 2 that which equation shall be utilized to obtain the runoff. So the step 3, we will actually estimate the runoff depth. So this is the equation that we are going to utilize as described in step 2. Okay, so let's obtain the runoff depth value for each day. For the day 1, P1 value is 82 mm. Substituting the value of 82 at P and substituting the value of 63.5 mm for maximum soil retention, we obtained Q1 as 36.16 mm. This is the runoff depth at day 1. Likewise, we can obtain the runoff depth at day 2 for precipitation 60 mm, and which is obtained as 20.19 mm. Okay, so in the step 4, let's find out the total runoff volume. So in the previous step, we actually obtained the runoff depth for each day, which is now displayed here. Q1 36.16 mm and Q2 20.19 mm. Now let's add both this runoff depth to obtain total runoff depth for the 2-day rainfall, which is obtained as 56.36 mm. Also, we noted that the catchment area or watershed area has been provided in the problem, which is 200 hectares. So if we multiply this area with the depth of the runoff, we will obtain the total runoff volume in the given catchment. So we have done exactly the same. 56.36 mm has been converted into meter by dividing it by 1000, and 200 hectare has been converted into meter square by multiplying 200 with 10 power 4, and we obtained the final response as 1,12,711 meter cube as the total runoff volume over the catchment. I hope you were able to understand each of the steps described here and will be able to solve the numerical problems which are being given to you in the form of assignments via NPTEL forum. To conclude, today we solved the 3 problems respectively to analyze the hydrological aspects of runoff, which is estimating the runoff volume. In the second step, we saw the correlation between rainfall and runoff, and the third question, we actually saw the application of SCSCN method. Thank you for your time. Stay connected for more videos to solve the numerical to solve the various numerical problems for the given assignment.